Alright, once again, good morning everyone, and welcome back to another exciting day in mathematics. Today I was going to dress up as a I guess a preppy or whatever. But but I'm always dressed up like that, I think. Right? But I'm also like, sometimes I can dress up like a hippie or a hip hopper. Bam! Anyways, so I don't really fit the mold, so I didn't dress up. Anyways, warm-up number 39 reads, write the compound inequality shown by the graph. They give us a number line. The first graph starts at 1, 2, 3, 4, 5, -5 in red, solid point, going to the right, arrow to the right. And then a green graph as well, overlaid on that, starts at +6, solid point, and that goes to the left, arrow to the left. And it's overlapping the other one. Number 2, it says solve 2x minus 14 over x squared minus 15x equals to 1. And number 3, it says write the equation of the function. They give us a coordinate plane. And they give us a line. And just to give you some reference points, that line is going through, let's say, -1, -4, 0, -2, what else, 2, 2, those points, I guess. You can use those reference points. I'll give you some time for that. Copy and go. Alright, let's see what we got. Number 1. Let's see. Compound inequality. Shani, what'd you get?
I got x plus -5 is less than equal to x is less than equal to 6.
Hands, have you got that? That is correct, yes. Dividing points are -5 and 6. They're solid points. There you go. How about interval notation? How would you write that in interval notation? Tell your neighbor. Interval notation for that. Alright. Sky, how would you write that? Bracket, -5, 6, and bracket. Hands, have you got that? Yeah, that is correct. And that was last night's home play, yes? I mean, with other things, but... Number 2. How about number 2? Mr. Q. Alright, I'm going to go over that one. So, we have a fraction equal to another fraction, is that correct? So we can cross multiply that times that. That gives me 2x minus 14 equals that times that, x squared minus 15x. So we have a quadratic equation. How do we solve that? It needs to be equal to what? 0. That is correct. So I'm going to bring all these to the other side by subtracting 2x and adding 14. Subtracting 2x and adding 14 to each side. 0 equals x squared minus 17x plus 14. Does this look familiar? Yeah. You got -17 and 14. Oh, my bad. The other way around. Made a mistake. Sorry. 14 and -17. There you go. What two numbers multiply give me 14 that when you add them give us -17? Think about it. Tell your neighbor those numbers. What two numbers multiply give me 14 when you add them give us -17? Alright. Jaden, what two numbers multiply give me 14 and when you add them give us -17? None. That is correct. There are none. So we're going to write for this one, for right now, guys, I want you to write non-factorable. Factorable. non-factorable. And what does that mean, Mr. Q? That for right now we can't solve it until I give you two more methods of solving quadratic equations that are non-factorable. Now, for those that were with me at 8th grade, hopefully you remember all different methods. You guys remember those? Yes? Okay, good. We already covered three methods, right? For solving quadratic equations, we use square roots, factoring, and graphing, right? Which ones are missing? Quadratic equation and completing the square. So we're going to get to those pretty soon. That's why I'm giving you these kind that you get stumped and you're like, well, I can't do anything else. Okay, that means that I need another method. Yeah, pretty good, right? Anyways, all right. So that was number 2. Let's go to number 3. Let me erase this. And they're asking us to write an equation for the function. So what kind of function is this? It's a linear. So yesterday we revisited and we said we start with what? Y equals mx plus b. But then we replace the y by f of x because now it's a function. I bring down the x. And now all I need to worry about is the slope and the y-intercept. So look at this blue line and tell your neighbor where it crosses the y-axis. Where does it cross the y-axis? Alright, let's see. How about Jessica? Where does it cross? Yeah. At -2, so that goes right here at the end. -2, okay. And how do we find the slope of any line? Any line. Tell your neighbor, how do we find the slope of any line? Alright, keep hearing the rise over run, but be more specific. Like, we pick 2 points and then calculate rise over run. Yes? So let me pick 2 points. I'm going to pick this point right here. And how about this point right there? Yes? So to go from here to here, I take how many steps up? 1, 2, 3, 4, up. And then I make a right turn. How many to the right? 2. So my slope is 4 over 2. And if I simplify that, that is 2x minus 2. Pretty good, yes? All right, copy the agenda for today. Here we go. Now today we're going to be graphing, guys. We need at least 3 coordinate planes from -10 to 10. If you have your graphing notebooks, do that. I still have some graph paper left. If you want to help yourself with that, that's up to you. They're over there. But you do need graph coordinate planes today. Agenda for today, warm-up number 39, attributes of functions. And your home plate for tonight, it's page 25 all only. 25 all only. All right. All right, your Nearpod code for you to follow at your own pace is J4GNP. J4GNP. And for those of you that are watching online, once again, you can use that code, log in, and in there you're going to find the practice page that I assigned for tonight. Everybody there? Yes? All right. And last night's home play, we said it was pages 12 through 15 evens only. And look what the note that I wrote for myself. Oh, and signed canvas grade screenshot, yes? So at this moment, you guys that are part of my class, go to Canvas, turn those 2 in, your home play and your signed screenshot. And then, once again, reminder, tonight's home play is page 25, and then we're going to get started, get your Cornell notes. You don't need a Freire model. And today we're going to be actually live on Nearpod. So I'll give you time to upload your home plate, set up your Cornell notes, get at least 3 coordinate planes set up. I'll give you a couple minutes for that. Those of you watching online, do the same, and I'll be right back. All right, here we go. So once again, if you are joining us on Nearpod, the code is on your screen. Type that in, and then you can follow along using that code. So as you log in, you should be at I can identify the attributes of functions. That's our objective for today. Let me switch screens. Oh no, you are at the warm-up, those of you that I logged in. And let me move this. There it is. All right, here we go. Our objective for today, I can identify the attributes of functions. I can identify the attributes of functions. I can identify the attributes of functions. So, if you notice, we're still dealing with functions. We're going to continue on with functions, but now we're starting to get really into the introduction of the different components of functions, okay? And today we're going to be identifying certain components and attributes in regards to what we see with certain array of points and such. And I want to go over that once more, guys, and just a reminder, there's tutoring Tuesdays and Thursdays after school. Be there or be elsewhere. But I really recommend you guys being here because we do plenty of practice and we actually are seeing certain things that maybe you missed in class. So please, pretty please. Okay, y'all ready? Here we go. So on your screen, there's a Ferrier model. Is that correct? Lock your toolbar. Tap on the little lock at the bottom. And I want you to get right on the screen an example of a function, a non-example, and a hashtag. We'll leave the definition for afterwards because by now I'm assuming you already know the definition, right? But just give me an example of what you think a function is and an example of what it's not. And one hashtag. I'll give you some time for that. 1 minute, copy and go. All right, now that you struggled a little bit and your noodle is barely turning those gears, turn to your neighbor and share what would be an example of a function and a non-example, so see if they remember. Turn to your neighbor, let them know what would be an example of a function. All right, so I'll give you another, 30 seconds? Write me an example of a function and a non-example, bless you, and a hashtag. All right, so on the screen you would see an example, yes, it has to say f of x, and then non-example, it's a one variable equation, and hashtag graph. All right, and some of you have like very intricate answers like this. Yeah, it's on your screen. Do you guys have that on your screen? You're like, oh yeah, that's exactly what I was thinking about, Mr. Q. Oh yes, there it is. All right, shall we move on? So, recap, have we been talking about interval notation? Yes, we're going to be dealing more with that today. So let's get right into the review of domain and range and the different notations. So, on your coordinate plane, that I had you make, or if you got one from over there. On the left side, copy that table, please. And this is example, let me zoom in. This is example Q. And it reads, graph the data given, write a function, write the domain and range in set notation and interval notation. And they give us the table X. For the domain, they give us -5, 2, 6, -1, 5, 4, -3. And for the range, they give us Y, which is -6, 3, 4, -1, 2, 7, and -2. Go ahead and copy that. And then on your screen, and once you're done copying that table on your paper, lock your toolbar and plot me your points on the screen. I want to see how well you're doing with plotting because I've been catching some mistakes on your home plate, and I just want to make sure that everybody's graphing correctly. So plot your points on the screen and also plot them on your paper. I'll give you some time for that. Copy and go. They want us to write the function. We'll leave that till the end, but they want us to identify the domain and range. Let's start with the domain. So if you have your highlighters, get those ready so like that we can use that to help us out. And here's a question. By looking at this data, since I'm going to start with the domain, I'm going to write domain. I'm looking at the x-axis, yes? Okay. However, before I go to those values of the x-axis, I want you to look at those points, all those points that we plotted, and tell your neighbor what is the point that's farthest to the left. What is the point farthest to the left of all that data? Tell your neighbor, turn to your neighbor, let them know what is the point farthest to the left of that data. Did you identify that point? Yes? Yeah, you should have said what? 5 and what? -6. So that means I'm going to draw a highlighter line all the way straight down that point. Is that correct? Remember, we always read it from left to right. Okay, so now that we have our farthest point to the left, I want you to tell your neighbor what's the farthest point to the right of all that set of data. What is the point farthest to the right? Everyone? 6-4, yes, which is over here. So I'm going to highlight that. Okay, and in order for me to avoid highlighting all this in between, because we know that we are focusing on what? The x-axis. So now we know that our dividing points are what? -5 and 6. So I'm going to write that here, -5 and 6. Being that it's the domain, what am I going to use in between? X, arrows to the left. And here's where some of you kind of miss it. Look up, and I ask, do we include -5? Let's find out. Here's my highlighter. Here's -5. Let me follow it till I see a point. There's my point. Is this a close point? Yes, so we put an equal sign. Now let's go to the other dividing point, which is 6. Dividing point 6. Let's follow the highlighter to the other point. Oh, there's nothing down here. Let me go upward. Is that a solid point? Yeah, so we put an equal sign. Can we write that in set notation? Yeah, solution set of x such that -5 less than or equal to x less than or equal to 6. Can we write that in interval notation? Yeah, I just use my dividing points, -5, comma 6. Since it look up, since it has an equal sign, that means this is going to have brackets. That includes the extremes. Are we doing yes? Good? All right. So, now that we got our domain, we're going to our range. Okay. So, I'm going to start from the bottom going to the top. What's the farthest point on the bottom? Tell your neighbor. Farthest point on the bottom. Yeah, so it's -5, 6, yes? -5, 6 is the farthest point down, so I'm going to highlight going through -6 of y, okay? And what is the farthest point on top? The farthest point on top. Yeah, y value is 7, but the point is what? 4, 7. So I'm going to highlight going through 7. There it is. So I don't need to highlight in between because we're working on the range. So that means my dividing points are what? -6 and 7. So write me the range in inequality, set notation, and interval. And this is example, what was example Q, was it? Yeah? Yes, it's Q. All right, good. All right. Dana, inequality. Tell me what to write for my range. F of x in between, yes. And then what are my dividing points? Uh-huh. 7 less than. Are the points included? Yeah, an equal sign. Yes, they are included because it's a solid point. Solid point. There it is. Set notation, solution set of f of x such that -6 less than or equal to f of x less than or equal to 7. Interval notation. Zachary. Bracket -6, comma. Bracket. Hands if you got that. All right. So this is a review of what we did last night's home plate, yes? The only thing on the home plate, they only ask you to do either one or the other notation. So, we good, yes? So let's see. It said graph the data. Did we graph it? Yes. Write a function. We still haven't got to that, but did we do domain and range using the different notations? Yes. Okay. So I'm going to erase the stuff that I did here on the graph. On the graph. Sorry. All right. Look up to the screen really quick. So I want to show you something. Don't do this. Some of you had started to do that earlier, but don't do this. But I am going to connect all the points so I can see which direction my entire data is heading. So if I start at the farthest left, what is my point farthest left? You said it was this one, yes? So what would be my next point? That one, and then that one, and then that one, and then that one. Some of you are like, why not this one? We're going from left to right, not from the bottom to the top, from left to right. So then that one, and then that one, and then that one. So far so good, yes? However, what do you notice? If we started down here, it's headed in which direction? Upward and to the right. Is that correct? All right. So, in order for us to write a function, we need to, this is what we call a best fit line. We need to fit a line that kind of mimics where the data is going. And let me show you my line that best fits all that data. Watch. I'm going to start down here. Is that pretty much following the pattern? It's close. Let me just move this a little bit more. There it is. And this one a little bit more. So here's the rule that I use when I get a line to fit my data. I start in the direction from the farthest point to the left, on the left, and I work my way in the direction that the data is going. So it's going upward that way. I try to intersect as many points as I can, and then those that I cannot intersect, I try to make sure that there's an even amount split from the top of the line to below the line. So look. How many points did I intersect? 1, 2, 3. How many points are above this line? 1, 2. How many points are below? 1, 2. Is that fairly balanced? It looks like fairly balanced. Now that I have my line on your paper, connect those 3 points, make your line, and we're going to write an equation for that line. Sketch your line, yes? All right, so how do we write a function for that line? Well, Mr. Q, didn't we do that on the warm-up? Yes. Y equals mx plus b. Yes? Yes. F of x equals blank x. Do we know what plus b means? Yes, that's where the line crosses the what? The y-axis, which is our y-intercept. What do you calculate that y-intercept will be? Tell your neighbor, where is it crossing the y-axis? Let me zoom in, because some of you are saying 0, 0. Let me double check to make sure that's true. What do you guys notice? Very close, right? So let's make it half, yes? Right there, just in case we missed it. Is that okay? All right, so what am I going to write here at the end? Plus 1/2. That's where it's crossing. This blue line is crossing the y-axis at half. Next, how do we find the slope? That's what m stands for. Of any line. Tell your neighbor, how do we find the slope of any line? Yeah, I heard rise over run, and I heard somebody say pick 2 points and count the steps or whatever. So let's see. I'm going to pick this point to this point. So how many steps up? 1, 2, 3, 4, 5 up. So I write 5 over. 1, 2, 3, 4. To the right. 4, and this is my function. All right? Show me the figures from 1 to 5. How comfortable are you with finding domain and range, different notations, and writing your function from a line? Okay, 4s, 5s, 4, 5s, okay. Let's do another one, yeah? Alright, I'm going to leave that one over here on the screen, but on your screen I'm going to move to the next one. And on your graph paper, do this next one by yourself. There it is. Example Super Q, and it says the same thing. Graph the data given. Write the function. You can do that at the end, but find me the domain and range and all the notations. And the table given, x is -8, 2, 6, -1, 5, 4, -7. And our range, or our y, is from 10, -3, 0, 2, 2, -4, -2. I'll give you some time. Ready, go. Alright, let's see where you're at. Continue working, but I'm going to start plotting the points as you are finishing up. Let's see. -8, 10. -8, 10 was way up here. 2, -3, 2, -3. 6, 0. -1, 2. 5, 2. 4, -4. And -7, -2. And if you got something like that, okay, good. So, my farthest point to the left, so I can start my domain, looks like it's this one. And if you got that, yes. And my farthest point to the right looks like it's this one. Which means that for my domain, I'm going to use the dividing point of -8 and dividing point of 6. -8 and 6. Hands if you got that. Yeah. X in between, less than or equal to, less than or equal to. Solution set of x such that -8 less than or equal to x less than or equal to 6. And interval notation, bracket, -8, comma 6, and bracket. Hands if you got that by yourself. Okay? I'm going to go with a range now. Range. Alright, let's see. What is the farthest point at the bottom? The farthest point at the bottom is this one right here. And it goes through y of -4, yes. What's the farthest point on top? Well, that's obvious. It's over here, Mr. Q. And it goes through the y of 10. So my range, or dividing points for the range, are what? -4 and 10. So that means I'm going from -4, less than or equal to f of x, less than or equal to 10. Set notation, f of x, such that -4, less than or equal to f of x, less than or equal to 10. Interval notation, -4 and 10, and both with brackets. And if you got something like that. Okay, good. Next, I'm going to go ahead and do my line. And it looks like if I go from left to right, this is the farthest point to the left, and it's going downward. You guys see that? Yes? So if I go downward, I'm going to go from here, let's see. And I'm going to try and connect to at least 2 or 3 points. About that? Will that work? Yes? Yes, Mr. Q? Alright, good. So let me write my function, y equals mx plus b. What is my y-intercept by looking at it? What do you guys think? What would be my y-intercept? Yeah, I see some of you saying 1. Yes, it's 1. So I'm going to put plus 1 right there. I'm going to bring down the f of x equals x. And now I just need to worry about my slope. How do we find the slope of any line? We pick what? 2 points. So I'm going to pick this farthest point over here and this one right here. So it's going downward. How many steps? 1, 2, 3, 4, 5, 6, 7, 8. Down 8. So that means I'm going to write -8 over, then make a right turn, and then we go 1, 2, 3, 4, 5, 6, 7, and there's my function. Yes? Okay, so what Cheney's saying, Mr. Q, isn't there that there's 2 of them repeating, okay? When 2 x are repeating, that's when it's not a function. When 2 y's repeat, it can be a function. So the only time that we need to check if it's a function is when 2 values of x are repeating. Are any x values repeating? No. So at this point, it is a function. All right, from 1 to 5, how can both do you feel with these? Yeah, 5 fourths, 5 fourths, okay. Look at this next one. And I'm going to leave the screen on your Nearpod so you can take a picture of that. But look at this next example. It says, example Star Wars 2, identify the rate of change between x equals 2 and x equals 3. They give us a table. For the domain, they give us from -2, -1, 0, 1, 2, 3, and 4. For the range, f of x, they give us 4, 1, 0, 1, 4, 9, 16. So they're asking us to find the rate of change. That means what's happening for there to there, or the slope. That's what rate of change means. So, for the sake of time, you can copy this from Nearpod, the slides. Well, for right now, just pay attention. So from what number to what number of x? From 2 to what? 3. So here's 2, x equals 2, and x equals 3. So how can we find the slope between those 2 points? How can we find the slope between those 2 points if they give you just numbers? Without graphing, by the way. Yeah, you use the formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which means I need to label these. So that means if this is my first one, this is x sub 1, y sub 1. That means if this is my second one, this is x sub 2, y sub 2. Alright, so if I go to here, so that means I need to substitute values in here and just paying attention. Here we go. And we already did this before. The only thing I'm revisiting now with the table. Here it goes. So, what is y sub 2? 9 goes right there. What is y sub 1? 4. Okay. What is x sub 2? X sub 2 is 3. And what is x sub 1? 2. And if I simplify that, this is 5 over 1, which is 5. Now, if I asked you to find me between, let's see, -2 and -1. These are x domain. Domain of -2, -1. What would you use? -2 and -1. And what do we do? X sub 1, y sub 1, x sub 2, y sub 2. You're going to have one of these for the home plate, okay? So, let me move on to the next one, which is the one I want to get to. And you don't have to copy it because I already gave you this one before. So look up to the screen. Look at this one. We've been plotting stuff that looks like this. I gave you plots like this, or started up here and down here, and so on, and found the domain and range. But for tonight, they're going to ask you stuff like this. What's happening to the graph for the domain from -2 to +3? What does domain stand for? X, yes? All right, so let me highlight from -2 to 3. -2 all the way to 3. Look at that portion of the graph. What's happening to the graph? Tell your neighbor, what's happening to that graph from -2 to 3? Some words. Give me words. Down. Yes. What else? Yeah, some of you are saying decrease. All that is correct. They just want you to describe what's happening. But check this out. What if they said find the slope. Tell your neighbor, what would you do to find the slope of this section of the graph? So you're like, what? Pablo, what do you think? What would I do? Plot 2 points, yes. One right here, and the other one down here, and then just count your steps. That's one way. Or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's what they're going to be asking you in tonight's home, please. Let me give you one more before you leave. How about domain? I want you to focus on domain from 4 to 8. Tell your neighbor what's happening to that graph from 4 to 8, domain 4 to 8. Marissa? Huh? It's going up or increasing, yes. It's going from here to here, it's going upward. And if I ask you to find the slope, once again, you plot your point here and there and count your steps, yes? Alright guys, so for tonight, home please on page 25. Let me see, where are we at? Have a good one, and I'll see you guys tomorrow. Bye. Bye guys.